Hey students, this is Sakshi, one of the faculty members here at Ask IITians. So today we'll be discussing the question paper for JEE Mains 2016. So I have this question paper containing 30 questions from chemistry. So now we'll be starting with all the questions one by one. Let's try to read down the questions. Let's try to get the concept which has been used in the question, and finally let's try to come up with the answers for all the questions. So without wasting any further time, let me begin up with the chemistry section. Now, regarding the very first question that have been asked, let me read out the question for you. Like the question was, which one of the following species is stable in aqueous solution? So you were given 4 species and we have to find out the maximum stable species in the aqueous solution. So if I am talking about aqueous solution and I'm trying to dissolve all the 4 species in this aqueous solution, so the question is you need to tell which is the maximum stable species. Let me write down the species one by one. The first is MnO4 3 minus, then you have Cr2 plus, so you have MnO4 3 minus, then you have Cr2 plus, then you have copper plus, and finally you are having MnO4 2 minus. So students, how we are going to begin up with the question? The very first thing that you need to keep in mind is to find out the oxidation state of all the elements in all the compounds. So let's say oxygen is in -2 oxidation state. So if I calculate, I'll get the answer as x minus 8 is -3. So x comes out to be -3 plus 8, which comes out to be +5. That means I can say manganese is in +5 oxidation state in this particular question. Now we have chromium, which is there in +2 oxidation state. Then we have copper in +1 oxidation state, and here manganese. X minus 8 is -2, so x comes out to be +6. So manganese is in +6 oxidation state. Now, one very important thing that we need to keep in mind, and this important thing is that, like, if you have any particular species, now that particular species will be more and more soluble and more stable only if it gets hydrated. And for the hydration of all the species, you need to follow if there will be some unpaired electrons. Now if a particular compound or the central atom is having certain number of unpaired electrons, then the hydration of that particular species is easy, and if the species will be more hydrated, we can say that the species will be more stable. Now if I go for option number A, B, C and D, and if I try comparing option number A and D, I can very easily judge that here manganese is in +6 and here manganese is in +5. Whereas we know that the stable oxidation state of manganese is +7. So we can say they are not the maximum stable species. Now coming out to the 2 leftovers, we have copper plus and we have chromium 2 plus. So if I ask you to go for copper, we know that the atomic number is 29, and for chromium the atomic number is 24. Now if I ask you to write down the electronic configuration, we say that this should be 3d10 4s1, and here I'll say that this is nothing but 3d5 4s1. Now if I ask you to write the electronic configuration for copper plus, it comes out to be 3d10. That means there are no unpaired electrons. Whereas if I ask you to go for chromium, the chromium 2 plus oxidation state will be having 3d4. That means there will be 4 unpaired electrons. Now since I told you, if a compound has got no unpaired electrons, it will not be easily hydrated and hence it will not be that stable. So the only left out species which will be maximum stable in the aqueous solution should be chromium 2 plus, and hence will be the answer for this particular question, because chromium is having maximum number of unpaired electrons and hence will be maximum hydrated and hence will be maximum stable. So students, this was the answer for the first question. Now let's move over to the second question that we do have. Coming over to the second question, let me read down the question for you again. The question says that the total number of orbitals which are associated with the principal quantum number 5 is. So let's say you need to tell what is the, let me say that the principal quantum number which is given to me in this question is 5, and you need to tell the maximum number of orbitals which can be associated with this principal quantum number. So students, now looking at the options, let me see the options again. The options are 25, 25 and 10. So 25, 25 and 10. If I'm not wrong, you should remember the formula about the number of orbitals which are associated with a particular quantum number. So the number of orbitals for a particular quantum number, let's say n, is written as n square. So if I say any principal quantum number is n, then the number of orbitals which will be associated with that particular orbital will be n square. If I ask you to put the things there, so 5 square will be 25. And hence I can say 25 will be the maximum number of orbitals which will be available or which will be associated with the principal quantum number 5 in this case. That means if I ask you to mark the options out of A, B, C, D and B are not the correct answers, whereas you can say option number A matches with what we have got, and hence this is the correct statement. So moving over from question number 2, let us come over to question number 3 now. The question number 3 says that, reading the question for you, for the reaction, there is a reaction which is given to you, and the reaction is A gas plus B gas is going to give C gas plus D gas. Delta H naught and delta S naught values, which respectively are given to be minus 29.8 kilojoules per mole and minus 0.100 kilojoules per Kelvin per mole at 298 Kelvin. Now you need to find out the equilibrium constant for the reaction at 298 Kelvin is. So let's do the question. The relation was A gas plus B gas was going to give us C gas plus D gas. So this is known to us. Also we have been given delta H naught is minus 29.8 kilojoules per mole. Also delta S naught is given to me as minus 0.100 kilojoules per Kelvin per mole. Now the temperature has been given to me as 298 Kelvin. So we need to find what is the K equilibrium for this particular reaction. Fine. Moving with the options and the answers, I can very easily say that if I am considering a situation at equilibrium. So considering the situation at equilibrium, I can say that delta G naught is nothing but delta H naught minus T delta S naught, where delta G naught is Gibbs free energy, delta H is enthalpy, T is the temperature in Kelvin, and delta S is entropy. Also we know one thing, that delta G is equal to delta G naught plus RT ln K equilibrium, where delta G is the Gibbs free energy at any particular temperature. So we can write it down as delta G is equal to delta G naught plus 2.303 RT log of K equilibrium. Following the above formula that I told you, I can write delta G naught is delta H naught minus T times delta S naught. So delta H naught is minus 29.8 kilojoules per mole minus 298 Kelvin into delta S is given to be minus 0.100 kilojoules per Kelvin per mole. So hey students, the question is easy enough, but the only thing which you need to keep in mind while doing this question is to take care of the units that have been written along with all the data points. Like here, if the unit is kilojoules per mole, be very sure that here also you are getting some kilojoules per mole in between. So on solving this, you will get minus 29.8 kilojoules per mole will be kept as such. Minus minus becomes plus. On solving it, you will get 29.8. See, Kelvin and per Kelvin, they got cancelled. So it becomes kilojoule per mole. So this comes out to be 0 kilojoules per mole. So what we got? We simply got the point as delta G naught is coming out to be 0. Moreover, you should remember that at the equilibrium conditions, so when we have equilibrium conditions, we can write delta G also equals to 0. So the relationship that we have written earlier, delta G is delta G naught plus RT ln K equilibrium, 0 is equal to 0 plus RT ln K equilibrium, which can also be written as 0 is equal to 2.303 RT log of K equilibrium. So that means log of K equilibrium comes out to be 0. Log of any quantity comes out to be 0 only and only if the quantity will be 1. So I can say that the K equilibrium value will be 1 in this case. Okay, now let me see the options which have been given to me. Let me write all the options one by one. The options given to me are, let's say A is 1 into 10 raised by 10, then 10, 1 into 10 raised by minus 10 and 1. 1 into 10 raised by 10, 10, 1 into 10 raised by minus 10 and 1. So I can say option number D matches with what the answer I have got and hence will be the right answer for this particular question. So now students, having done with this particular question also, let us move over to the another option. The another question that we have is question number 4th in this case, and this question number 4th comes out to be, which one of the following complexes will consume more equivalents of aqueous solution of AgNO3? That means what? You have been given aqueous AgNO3 solution. And the question basically wants us, like there are 4 compounds, you need to tell which compound will be using maximum solution of AgNO3. So let me try to write down the equations for all the reactions. I can say that AgNO3 plus the compound. And now the relationships will vary according to the compounds that we have. Taking the first case, you have CrH2O5Cl Cl2. CrH2O5Cl Cl2. If it is made to react with AgNO3, you will be getting, so see, since according to what concepts you must be knowing about primary and secondary valencies, I can simply say that since these 2 chlorines are little free and hence they will be taking participation in the reaction. So these 2 chlorines will be combining with 2 moles of AgNO3 and they will lead to the formation of the precipitates 2AgCl plus you will be getting CrH2O5ClNO3. And this will be whole twice. That means here you needed 2 moles of aqueous AgNO3 in this particular equation. Now if I ask you to go for the second point says that you have Na3CrCl6 plus AgNO3. Now in this particular question also, if we move ahead, we can simply say that NaNO3 will be formed as a new compound in this reaction. So since there are 3 sodium outside, so there will be 3 moles of AgNO3 which will be required for the reaction. And hence you will be getting the options as you have 3 NaNO3 that will be formed plus you will be getting Ag3CrCl6. Now the problem with this reaction is, again see, NaNO3 can break up into the compound because it's very ionic, and since you have aqueous solution, it will be further going to form Na positive and NO3 minus. And again here we cannot say anything about the stability of this new compound so formed. So again I am not very sure about whether this reaction will go in the forward direction or not. So let's mark this option as a little difficult option for this particular question. Now to move for the third example, the third option that we have is Cr, then you have H2O 6Cl3, and we are going to react it with AgNO3. Now again we can see here that there are 3 chlorines outside this coordination sphere. So there will be 3 moles of AgNO3 that will be required. And hence you will be getting 3 moles of AgCl as precipitate to be formed, and you will be getting CrH2O6NO3 thrice. That means here you will have 3 moles of AgCl formed because there were 3 moles of AgNO3 which will be used in the reaction. Again, coming over to the fourth point, you have Na2CrCl5 and then you have H2O. So again you have 2 Na, that means 2 cations are there outside the coordination sphere, so they will be reacting with AgNO3. How many moles of AgNO3 will be required in this particular case? You will say since 2 Na are there, so 2 moles of AgNO3 will be required, and hence you will be getting 2 moles of NaNO3 and some another compound. Again we are not very sure about the stability of this compound. So if I am to choose the best option out of the 4, we can say that the first one and another 2 option, the fourth one, they cannot be the correct answer because you need more number of AgNO3. So the more number of AgNO3 have been used in option number 2 and 3. And since we'll be getting the complete precipitates of AgCl as per in this particular example, so I'll say option number 3 will be the correct option out of the other options available. So students, this was question number 4. Now let us move over to question number 5 in this particular case. Question number 5, it says that, now the question number 5 is, the hydrocarbon with 7 carbon atoms containing a neopentyl and a vinyl group is. That means you have to tell such a hydrocarbon which has got 7 carbon atoms. Also it must be having a neopentyl group and a vinyl group. Now see, if I go through the options, a neopentyl, as per you know that whenever we'll be starting from the second, like if we start from the end of the chain, any end of the chain which contains 2 methyl groups will be called as a neo group. So let's say this is a neo group. For example, if I start from here, if I say this is the end of the chain, starting from the end of the chain, if the second last carbon has got 2 methyl groups, it is nothing but a neo group. Moreover, you have also been called that you have a vinyl group. So if a vinyl group is there, it must be C double bond C. So if I combine the two, you will be having CH3 C CH3 C double bond CH2 and let's say an H here. So let me count the number of carbon atoms which are so I must have missed one thing. So since I have been asked to form a neopentyl, so I must be saying, so you have a C CH3 CH3, then I have a C group, another C, and then double bond CH2. So let me count 1, 2, 3, 4, 5, 6 and 7. So 7 carbon having one neopentyl group and a vinyl group. So this will be named as 4,4 dimethyl pentene. Pentene, or I can also call it as pent-1-ene. So let me now look into the options which are available for this particular question. The options that are there are isopropyl 2-butene, isopropyl 2-butene, which was not the correct answer. Then we have 2,2-dimethyl 3-pentene. This is a wrong option. Now why this is a wrong option? Because if this would have been the correct option, we would have meant by numbering from here 1, 2, 3, 4, 5. I cannot number this as at the second position, because the numbering should be given to the highest priority group, which is nothing but the double bond here. So this is also not the correct option. Then we have 4,4-dimethyl pentene. And hence we can say this is the correct option. And the fourth option, let me simply have a look, 2,2-dimethyl 4-pentene. Again, this cannot be the option. So out of the 4, we have chosen option number 3 as the correct option for this particular question. Now done with this question, let us move over to the another question.